Arteries and veins are some of the most important structures that we have in our body. Today we're going to talk about what they are, how they work, and some other interesting facts. So let's get started. All right, so in order to understand what these things are and how they work, we have to take a little bit of a detour and discuss how the heart actually pumps blood. So let's zoom in here. So we know two things. One, the heart contracts, and when it contracts, it pumps blood to the place it needs to go. The heart also relaxes, and when it relaxes, it fills up with blood. So I'm going to break this down into two parts and then bring it all together. So let's talk about the right side. So the right side, when the heart relaxes, is going to draw in blood from these big old veins. The blood's going to flow to the right atrium. And think of the atria like these storage centers. I'm not going to get too deep into it. It's eventually going to flow into the right ventricle. Now, once this happens, the heart's going to contract. When it contracts, it's going to flow through this thing called the pulmonary trunk to the lungs. So let's pause. Why does the blood need to go to the lungs anyway? Well, it turns out that this blood has no oxygen. It's deoxygenated. That's the long word for it. So let's talk about what happens when that blood goes to grab some oxygen. So here in our lungs, we have these branches of alveoli, these little sacs that contain air, specifically oxygen. So when we breathe in, we're breathing in that oxygen. And as the blood flows around these alveoli, these thin layers called capillaries, the blood makes a little wager. It's like, okay, I'll give you my carbon dioxide if you give me your oxygen. And this is called gas exchange. Now, this is more complicated than what I'm making it out to be, but this is simple for this video. And when that happens, we breathe out that CO2, and the blood now has oxygen to give to the organs and the cells as it needs. So it goes into circulation. Now, we're going to talk about this side. So the heart relaxes, it fills up with blood again. Now we have oxygen, and it's going to go into the left atrium, to the left ventricle, and then it's going to pump. Now, when it pumps, it's going to go through this big old artery called the aorta. We're going to talk about that in a second. Now, why is this important? The aorta happens to feed the rest of the body. These go up to your head and your arms and your neck, and then it stretches down to your stomach, your legs, all the rest of your body. Let's bring it all together. It would have been a little confusing to talk about it all in one go. The heart relaxes. It draws in blood from these big veins that's not oxygenated. And then it also draws in oxygenated blood from the lungs. And then it pumps. When it pumps blood to the lungs to get oxygen, and it pumps blood that already has oxygen to the aorta through the rest of the body. So this is what happens when your heart pumps blood. So let's talk about arteries and how they play into all of this stuff. Okay, what are arteries? So arteries are these tube-like vessels, right? It's gonna be a bad picture, but these tubes, these long tubes that are made of muscle and tissue. So I don't have a cross section, but they have muscle and tissue that surrounds them so they can be sturdy and do their things they need to do. Now, arteries, you can think of like a delivery highway system. They're a highway system by which nutrients can be carried, blood, oxygen, so that oxygen is hitching a ride with the blood to go to where it needs to go, hormones, and really anything else that your body needs to function. Now, this highway system is a little different depending on where you are in the body. It's flexible. So the arteries that are close to the heart are more elastic, a little more stretchy. And the ones that are further away are a little bit more muscular, a little bit more rigid. I'm not going to explain all of that, but just know that that's how it is. So we spoke about the aorta earlier. The aorta is this major artery, provides blood to the whole body. Now the aorta stretches up to other arteries and gets the arms and then the neck and all that good stuff. And then it stretches down to what's called the abdominal aorta. Now this is a thick, big artery. This is the biggest portion in the body. And this provides blood to all of these lower organs. So this is another reason why the aorta is incredibly important and why arteries are important. They give oxygen to these organs. And then we have the femoral artery, which is down here. like your thigh area. It really feeds blood to the rest of your lower half. So this is a basic overview of arteries. So let's talk about blood pressure, because arteries and blood pressure are very closely related. So what is blood pressure? Almost all of us, hopefully, have had our blood pressure taken, but some of us might not know what it even is. So let's talk about what it is. So it's the pressure. Let's stop there. What is pressure? Pressure is the force exerted on an object, really on like the surface of an object. That's a very basic definition. I'm not a physicist, but if you press your hand down on a table, you're exerting pressure. So this is the pressure of blood against the walls of arteries. So we mentioned before that these arteries are made of this muscle and tissue. They have walls. So blood pressure is the force at which this blood hits these walls. Now, why is that important? Well, let's talk about these numbers, right? We see these numbers in our blood pressure, but we may not know what they mean. So this top number is the systolic reading, or stands for systole. Now, what is systole? Let's zoom in a little bit here. Systole is when the heart contracts and blood flows out, so the heart pumps. Now, why is this number higher than this number? Well, let's think about it. We spoke earlier on how when the heart pumps, it pumps blood mainly to the rest of the body through the aorta. This number is higher because more pressure is needed to get blood to the rest of the body. So because of that, the number has to be higher because it's a higher pressure system. This lower number is diastolic. This diastole is when the heart relaxes, the blood flows in, the heart fills up with blood. It's a lower number because it's a lower pressure system. It doesn't need to have a high pressure to draw blood from the veins. We're going to talk about veins in the next slide. So that's the very bare bones explanation of blood pressure. And now you know what systolic and diastolic means. So let's talk about veins. What are veins? So veins are these tube-like vessels, just like arteries. They're oftentimes a lot smaller. They carry blood to the heart. So arteries carry blood away from the heart to get to the organs and things like that. Veins carry blood back to the heart. It's a very smooth functioning system. And this blood happens to have no oxygen. Why? Well, the blood that had oxygen, it already dropped off the oxygen. So it drops off the oxygen and then it goes back into circulation to pick up some more. And at any given time, you have about 70% of blood in circulation comes from your veins. And you got a bunch of veins here. They're kind of all over the place. I don't have time to get into all of them, but you see what I'm saying. So veins are very different in structure than arteries. They have these things called valves, these almost like doors that open and close. And these valves prevent backflow. And I'm going to talk about what that is in a second. The blood will move in, stop, the valve closes, and it'll move in again once it opens, and it's slow. As the heart draws in blood, it'll move more and more and more till it gets to the heart, and then it'll grab some oxygen and start the whole process over. One quick thing, why are veins quote unquote blue? Well, veins aren't actually blue. I'm sure most people know that. They're blue because skin does not absorb blue light well. So blue light's reflected back at us. If you recall some of the other videos I made, let's talk about white light. Let's say white light bounces off of a red apple. Well, it just happens that this red apple absorbs every single color except red, and that's why red is reflected back at our eyes. In this case, the skin absorbs all the colors except blue, and blue bounces back. Well, blue-green. Some people see some green. But anyway, that color bounces back. That's why we perceive them to be a different color when they're really not a different color. All right, the last slide, we're going to talk about the capillary bed and varicose and spider veins. So what is this thing over here? So capillaries are where gas is exchanged, like we said earlier with those alveoli. Once the blood drops off what it needs to drop off, the oxygen in this case, it's going to go back into circulation through major veins in the body. The major organs and systems have veins. These other highway systems that take the empty trucks and go back to the heart to fill them up again to go drop off more oxygen. You can think of these like currency exchange centers, like the ones at the airport when you're traveling internationally. You give some currency local, and then you receive the currency from the place you're trying to go. It's an exchange. So that's how that works in a nutshell. So over here, we're going to talk about varicose veins and spider veins. I thought these were the same thing, and I was proven wrong. So let's talk about them. So varicose veins, as you can see here, these are varicose veins. They're thick, they're twisted, they bulge, and they often cause pain. This can happen if you're overweight, through age, and other stuff like that. Now, the reason why this happens outside of a bunch of other factors is we have these valves. I spoke earlier how these valves prevent backflow. Here we have a normal flowing vein. It flows in, it closes, it flows in. Here you can see that these valves are all messed up. And because of this, the blood will flow in like normal, but because this valve's messed up, it'll also flow back. And then this part will blow up like a balloon, which is why you see, zoom in here more, you see it's all bulgy. It's because the valves aren't working and they're all blown up. And then you have spider veins. Spider veins are less intense. They look like little spider webs, and they can happen from standing too long, sitting too long, pregnancy hormones, all kinds of other stuff. And this is what they look like. Some of us might have them, but that's kind of the gist of them. And there's a lot more to it, but I don't have time to get into it. So let's go through the summary and refresh ourselves with all the things we just learned. So we spoke on the heart flow. We spoke about how the heart fills up on this side and on this side, and then it contracts and pumps blood to the lungs to get oxygen, and then pumps blood through the aorta to the rest of the body. And we talked about gas exchange, how the blood makes its wager. I give you my CO2, you give me your oxygen. Then we spoke about arteries, these vessels made of muscle and tissue that are the highway systems. They carry the nutrients, the oxygen that our body needs. Then we have major arteries, the aorta, abdominal aorta, femoral artery, and there's a lot more to it. And then we spoke about blood pressure, how blood pressure is the force exerted from blood against the walls of these arteries, how systolic was the heart contracting and blood flowing out. Diastolic was the heart relaxing and blood flowing in, which is why this number is higher than this number. And then we briefly learned about veins, these smaller tube-like vessels that carry blood without oxygen to the heart to grab some more oxygen. And they have valves that keep blood from flowing back. And they're blue because the skin reflects blue light at our eyes. And then we spoke about these exchange centers in our body where blood is depleted of oxygen and it goes back into circulation to grab more, and the process moves on and on and on. Then we spoke about varicose veins and spider veins, these issues with valves, the vein structure, and then we also discussed some of the reasons why these things happen, you know, overweight, age, pregnancy, etc., etc., etc. So that's all I got. I hope you guys learned a lot. I'd learned a decent amount from this video. As always, thank you so much for watching and listening. Please like, comment, and subscribe. Tell your friends, and I'll be back soon with another video.